Hello, welcome to Math Expressions. My name is Alexander Madoka, and in today's video, we will be looking at our next topic, which is arc ratio. In case if you are meeting us for the first time or you are watching our video for the first time, there is a teaching series that have been going on in this channel. So I will advise you to go and watch our previous videos so that you can see how the lecture is being organized and so that you can as well follow along with what we are doing in this channel. Now, without wasting much of our time, let's get started with what today's topic is all about. Now, this topic here, arc ratio, might be probably new to you, but don't worry. By the end of this video, you will know what this topic, you have a full understanding of what this topic, arc ratio, is all about. Now, let's look at what this topic means. First of all, arc ratio is the ratio of a chord to an arc of a circle. Now, this is a segment, and in this segment, we have the length of arc, which is the arc length, and the length of chord, which is the chord D, the length of arc, which is L, and angle of this segment, which is theta. Now, arc ratio is the ratio which shows the relationship that is between these three parameters that you are seeing here, which is the length of arc, the chord, and the angle of this segment. Now, let's break this down. Considering these three parameters, L, D, and theta, in the above diagram, there are three special behaviors you will notice about them as the segment increases. Now, let's look at that three special behavior. The first thing you will notice is that the arc, which is L, increases as the segment increases. This length of arc here increases as the size of this segment becomes bigger. Then, number two, the angle theta decreases as the segment increases. As the size of this segment increases, this angle here becomes smaller, 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 and smaller till it finally becomes 0 when this segment turns into a full circle. Then, number three, it says the chord D increases and then decreases as the segment increases. What does this mean? Now, when this segment first started, when this segment was very small, when the segment is small, this length of chord here is very small, and as the segment continues increasing, the chord increases as well as the segment increases until it reaches its maximum length at the center of the circle. Then after the center of the circle, the length of this segment of this chord here will start decreasing until it will finally become 0 here as when the segment turns into a full circle. Now, relating these three parameters as a function, we can say that x is equals to theta, while f of x is equals to d all over L. This function gives the best definition of the relationship among those parameters. This function we just defined here, it is the function that tells how these three parameters relate. It is the one that defines the best way in which these three parameters relate to each other. Now, let's try and create something meaningful from this function that we just defined here. Okay, let's look at derivation of f of x. Let's know if we can create something more meaningful from this function we have defined here. Now, let's look at this formula. This is the formula for finding the chord. This is the formula for finding the chord of a segment, which says D is equals to 2 times R times sine theta, while L is equals to 2 times open bracket pi minus theta close bracket all over 2 pi times 2 pi r, which is equals to 2 times open bracket pi minus theta close bracket times r. This first formula here is the formula which we use for finding the chord of a segment. Why the second form? Okay, using this angle, like this formula here, we can use it to find the chord of this segment using this angle here. While the second formula, this formula here, we can use it to find the length of this arc of this segment using this angle here as well. Now, note before, all this formula which we just used here, theta is in radian in these formulas which we just use here, which we just define here. theta is in radian. Okay, this implies f of x is equals to d all over a, as we defined before, which is equals to 2 times r sine theta all over 2 times open bracket pi minus theta close bracket times r. R will cancel r, 2 will cancel 2. At the end, we are left with f of x is equals to d all over a, which is equals to sine theta all over pi minus theta. Okay, if x is equals to theta, f of x is equals to sine theta all over pi minus theta. Now let's replace f of x with delta theta. We will have our equation, our function will look like this. Delta theta is equals to sine theta all over pi minus theta. This function here is called delta function. Now if delta theta is equals to d all over a, which is also equals to sine theta all over pi minus theta, then delta inverse of d all over a is equals to delta inverse of sine theta all over pi minus theta, which is equals to theta. This second function is called inverse delta function, the inverse of this first function which we define here. Okay, now this function that we just defined, the next thing we do is to look at how the graph look like, the graph of this function. Of course, this is the function, and let's look at how the graph looks like. Now in this graph which you have plotted here, at the x-axis, let me zoom in. At the x-axis we have theta, while at the y-axis we have delta theta. Now if you plot the graph of this function, this is exactly how it looks like. The function ends at pi. This angle here, it reaches its maximum limit at pi, and at pi in the x-axis and at 1 in the y-axis. Okay, this means the limit of this function as theta approaches pi, sine theta all over pi minus theta is equals to 1. The limit of this function is 1 as theta approaches pi. As theta approaches pi, the limit of this function is 1. Now delta theta is equals to sine theta all over pi open bracket 1 minus theta all over 180 degree close bracket. This is the formula for finding delta function if your angle is in degree. Note before, theta is in degree. If you're interested in finding the delta function in degree, this is the formula you will use as it is circled here, as you can see it inside this rectangle. So this is the formula you will use for finding delta function in degree, while the first formula, which is this one, is used for finding delta function if the angle is in radian. Now let's look at worked example and see how this function behaves in action. Okay, now the first question we have here, it says what is the arc ratio of 78 degree? Now solution. In this solution, we will solve this question in two ways. The first way is that we will solve it in degree, and the second way we will solve it in radian to see if we will arrive at the same result at the end of each solution. Now the first one is in degree. Theta is 78 degree from the question. Then delta theta is equals to sine 78 all over pi times 1 minus 78 all over 180 close bracket. From this formula for theta, that's the formula we are using. So if you do the calculation, the numerator will give you sine 78 will give you 0.9781, while the denominator will give you 1.7802. Now if you divide this fraction here, we have delta theta is equals to 0.5494. That's the formula we got using the function when theta is in degree. Now let's use the function when theta is in radian. B, if theta is in radian, the first thing we will do is to convert this theta to radian. Theta is equals to 78 degree from the question. Now converting this angle here to radian, we will say 78 times pi all over 180, which will give you 1.3614. this is the formula for converting angle from degree to radian. Then that means at the end of it you have 1.3614 radian. Delta theta is equals to sine 1.3614 all over pi minus 1.3614. This is the formula for this is the function, how the function is if theta is in radian. Now if you do this calculation, the numerator, which is sine, this sign will give you 0.9781, while the denominator will give you 1.7802. If you divide the ratio, if you do the fraction, then delta theta will give you 0.5494 as well, as we got from this function when theta is in degree. Okay, now let's look at example 2. Example 2 says a segment whose arc length is 7.45 centimeter and its length of chord is 4.5 centimeter. What is the angle of that segment? Okay, it said leave your answer in degree. Now we're getting to the interesting part of this function here. Now, let's use the parameters. L is equals to, which is the arc length, L from that diagram is equals to 7.45 centimeter. D is equals to 4.5 centimeter. Y theta is unknown, which is the angle we're supposed to find. Then delta theta is equals to D all over L, which is equals to 4.5, which is D all over 7.45. If you do the fraction, delta theta will give you 0.60403. Then theta is equals to delta inverse of 0.60403. Theta will give you, from this function, theta will give you 85.44. Now let's use our calculator to confirm that. If you use our beautiful calculator, let's use inverse function. Okay, delta inverse of 0.60403 close bracket equals to, we have 85.44 to the near. So if you run the result up, we have 85.44 degree. This function here, as you can see, when we use our calculator, we got the same answer from what we have solved. Now, alternatively, you can also use calculator to calculate this if you don't want to go all through the stress of using all this formula. Now, if we use our calculator to find the arc ratio of 78 degree, now let's use our calculator again. That will even be a quicker way. Let's clear the old answer. So let's go to the normal function. Delta 78, you close your bracket, is equals to 0.54944. Like if you round it up, you can see we got the same answer here. So from our calculator, as you can see, our beautiful calculator gives the same answer as we calculated in this, as we calculated on our whiteboard here. So that is it for this video. I have tried, in this video we have explained what arc ratio is all about. We also look at two most important functions inside this arc ratio, which is delta function and inverse delta function. And at the end of it, we use those functions and see how they behave in action.